Okay. I'm re-recording all those videos from yesterday, so starting from the beginning, and it's backwards for me, but it won't be for you when I hit stop and then put it online. It says, what is the net capacitance of two capacitors connected, one in parallel? We talked about this in class on Friday, and then we will review this, and then in series, we kind of got partway through it, but it kind of got cut off by that alarm telling us that it was time to go. And so I kind of have a schematic here. This is in parallel. Notice kind of a wire coming in that splits. Each one of these sees a capacitor, and then it comes back together. This is connecting in parallel. And then in series, it's like a wire, a capacitor, a wire, another capacitor, and then exiting. And each of these are equivalent. That says C net, right? So these two capacitors are equivalent to just one capacitor. These two are also equivalent to one capacitor. And the question is, what is the equivalent capacitance of each of these individual capacitors? And to help see this beyond a diagram, I didn't have any capacitors laying around, but I'm going to use batteries. So what I have here is, there we go. I have batteries that represent capacitors. This is an illustration of what it looks like if they are connected in parallel here. Notice we kind of have one connection, connect up to each battery, and then or capacitor, figuratively speaking, and then that wire comes back together. And let's see if I can, so here, there's the setup, right? And you would have what is called a potentiometer, but I don't have one, but it would look like this. This is a ohm meter or voltmeter, but a potentiometer would look very similar. And what you would do, you would say, okay, I could place each wire from the potentiometer on either side, and on the readout, it would list that equivalent capacitance of this circuit in series. No, this is in parallel here. If it were connected in series, let's just quickly rearrange this, I'll show you. It might look like this very quickly. Coffee. There we go. Notice we have one end of the wire connects to a battery or capacitor, wire, battery, and then out to the other end. And I would connect my potentiometer, which we'll look at in class, to either side here, and it, on the display, would read that equivalent capacitance here. Cool, so let's just quickly review, it won't take long, what the equivalent capacitance is in series. That's the one we just looked at. Going back to the diagram here, in series is one, then the other, and then you know that potentiometer goes on each side. What is the equivalent? Oh no, let's do it in parallel first. I'm sorry. Parallel is what we'll do first. That was the first one that we looked at. The wire splits, CD's capacitor, and then comes back together. That was kind of the easier example that we did at the end of class Friday. And what we kind of came up with is that C net is just C1 plus C2. C1 plus C net is C1 plus C2 if they're connected in parallel. And our argument kind of was, looking at that formula, what is the net capacitance? It's epsilon naught A over D. I'll post these notes on the Canvas as well. C, in general, is that constant times the area over D, the distance between the plates. And it makes sense that we are going to add the capacitance, because it's that where we kind of have an area 1 here for the charge to build up, an area 2 for the charge to build up, which is going to be a net area, which is the areas add in the same fashion that the capacitances add. And that's how we would find the net capacitance in parallel. And we could demonstrate that with a potentiometer if I had one, but I don't. But we will might look at those in class or in lab. Cool. So I'm going to push pause for now, and then take a look at what happens in series. This one is a little bit trickier, and we'll look at some examples in series as well. Okay, see you next time.